Insertion sort. Insertion sort is a comparison based sorting algorithm that builds the final sorted array one element at a time by picking an element from the unsorted part of array and placing it at the correct position in the sorted part of array. At this point, you may have a doubt. This is the exact same statement that we made in the previous two lectures. That is, when we were learning about bubble sort and selection sort, we made the exact same statement that we'll pick one element from the unsorted part and we'll place it in the sorted part correctly. But there is a difference. The difference is that in case of bubble sort, you specifically picked the largest element from the unsorted part of array. And what about selection sort? In that case, you specifically pick the smallest element from the unsorted part of array. But in case of insertion sort, you just pick the next element from unsorted part of array. Thereafter, the technique is about how do you place it correctly in the sorted part. The reason is, in case of bubble sort, because you are picking the largest element from here, placing is not a big deal because you already know whatever is coming from the unsorted part is the largest element. So you have to place it in the rightmost available position. Similarly, in case of selection sort, you already knew that whatever is coming from unsorted part, that is the smallest available element. That means you have to place it in the leftmost position that is available. But in case of insertion sort, you have no idea of what element is coming in. Anything can come in from the unsorted position, which means this time you have to put your efforts in identifying the right position to be inserted. So in short, you can understand that in the previous two sorting algorithms, the core of the algorithm was about how you pick the right element from unsorted part. But in case of insertion sort, the core of the algorithm is in how you insert the right element into the sorted part. So let us understand how this is done. And I'll tell you one more thing, that this insertion sort algorithm, this works exactly like how you arrange playing cards. If you have some playing cards with you, this is a set of playing cards and you want to sort these cards in your hand. How do you normally do this? That exact procedure is what is called as insertion sort. You will take the first card and you will place it on the left side. Then you will take the right card, second card, and you will place it in the right position here. What will you do then? You will just pick the next card, the third card, and then you will see where exactly should you place. Whether it should be in the leftmost position, should it be between the two cards that are present, or at the end. So like this, when you are inserting, you would see which is the right position for this card to be inserted. So the same thing is called as insertion sort. So we'll take an array and try to understand. That will be easier. So if this is the array that you want to sort using insertion sort, what will you do? These are the elements of the array. You should have a sorted part and unsorted part. So to begin with, in the sorted part, you will have only one element. So how is this one element sorted? Because there is only one element, there is no order to be maintained. It is by default sorted. So you will start insertion sort with the second element. How do you do this? You will take the second element, you will see which is the right position, you will place it. So at this point, your first two elements are sorted. Let us say you reached a position where first three elements are sorted. And let us understand how exactly are you determining the position to insert the unsorted element. Okay. So consider that this fourth element is the one you want to place. And you want to place it in this sorted part. This is the sorted part. The algorithm you use is like this. You will see the last sorted element. You know this is already in the sorted order, that is ascending order. What will you do now? You will take the last element and see whether this last element is larger than the element under consideration or not. So element under consideration is the first element from the unsorted part, this one. You will see whether the largest element in sorted part is larger than the element under consideration or not. If it is larger, what will you do? You will move this element one step to the right. So at this point, you may again have a doubt. If you move one step to the right, it will take the position of the element under consideration. Then what will you do with this? How will you find this element again? So in insertion sort, in every pass, what you do is you always store this element somewhere else. You will have a variable. In that variable, you will store this element first. After that, you will start the procedure on the unsorted part. So you will move this element to the right. Again, in the next available element in sorted part, you will do the same check. That is, whether this element is larger than the element under consideration or not. If it is larger, you again going to move it to the position to the next. So you will continue this till the point you see that these elements are larger than your element under consideration. That is the element that initially existed here. Whenever you reach an element which is smaller or equal, in that case, what will you do? You know this position is empty now because you moved this element to the next position. So if you see that the first element, this is smaller than the element under consideration, then you'll insert the element under consideration, whatever you stored in this variable, you'll insert it in this position, which means at this point you will have 4 elements sorted. What we'll do, we'll take example numbers and understand this, so that will provide more clarity. Here I just wanted to tell you the algorithm first before we manipulate numbers. So as we did in the previous lecture, we'll take the same set of numbers because I want you to exactly know what is the difference between manipulation of these different indices, different numbers between different sorting algorithms. So this is your array, and in this array you have the numbers 42, 70, 12, 30 and 24. These are the numbers. You want to arrange them in sorting order. So how will you start? Initially, you will consider this as the unsorted part and this as the unsorted part. This whole part is unsorted. What will you do in the first pass? You will consider 70 as your base element. So you will store it in a variable. In this variable, you will store 70. What will you do then? You will see whether 42 is larger than 70. 42 is not larger than 70, which means you will keep 70 in the same place. This is where you want to insert 70. So your first 2 elements are sorted. What will you do? You will move this barrier here. So first 2 element, this is your sorted part now, and this is your unsorted part now. What is the element under consideration now? 12. What will you do with 12? You'll check whether 70 is larger than 12. 70 is larger than 12 is right. So you will move 70 one place to the right. So 70 will come here. Next, you will consider 42. You will see whether 42 is larger than 12. 42 is larger than 12. It is correct, which means you have to move 42 to the right. At this point, you are already done with all the elements in the array, which means you can comfortably insert 12 here. So how many passes are done now? Including this, 2 passes are done. So at the end of pass 2, this is the order you have, and you have 3 elements sorted. So this part is sorted and this part is unsorted. What is your next pass? In the next pass, you will consider 30 as your base element. You will store it in a variable. You have to see whether 70 is larger than 30. It is correct, which means 70 will be moved one step to the right. Then you will see 42. Is 42 larger than 30? Yes, it is. So 42 will also be moved one step to the right. 12. Is 12 larger than 30? It is not. So you don't have to move 12. You will insert 30 at this position. So at this point, you have 4 elements sorted. This much is sorted. 1 element is remaining to be sorted. This is in unsorted position. So this time your base element is 24. You will check 70. Is 70 larger than 24? Yes, it is. So you have to move 70 to the right. Is 42 larger than 24? Again, yes, it is. So 42 moves to the right. What about 30? It is also larger and moves to the right. What about 12? 12 is smaller than 24. So you have to insert 24 here. So at this point, you are done with complete array and you have a sorted array as the output. So this is insertion sort algorithm. What we'll do next is we'll write the pseudocode, and after writing the pseudocode, we'll analyze space and time complexities of this algorithm. So at this point, it should be clear for you why we are calling this as insertion sort. Why is the name insertion sort? The reason is you have a sorted portion and you will have an unsorted portion. What are you doing? You are inserting the element from unsorted portion into the sorted portion. So basically you are inserting it to the right position. That is why it is called insertion sort, right? So that is where the name comes from. Let us see the pseudocode and understand how it works. So while writing the pseudocode, what should you have in your mind? You should have in your mind that you will have one loop which will go from the second element till the last element. This is what the outer loop will be. And then what should there be? An inner loop should be there, which will come in reverse order from whatever element you are presently considering as base element. Whatever be the element picked in the first loop, from that element you will come towards the left, and what will you do? Till the point you are meeting larger elements, you will move them one step to the right. So this is the algorithm you have to follow. So let us write this pseudocode and understand. Insertion sort of array. You have an array, you have to sort this array. How will you do this? In order to do this, first you will have a variable for length of array. So I'll call it n. N is equal to length of array. After this, what should I have? I should have the outer loop. What should the outer loop do? It should go from for I is equal to, I should not start from first index because first index is already sorted part. So I'll start from index 1. That is, first index is index 0. So I'll start from index 1, which is actually second element. 1, 2, till what point? Till the end of array. Array ends at n minus 1. What should I do whenever I enter this loop? First thing, I should pick the base element. What is my base element? My current element. My current element is AR of I. This is my current element. I'll call is the base element. Then I should have a variable called J, which I'll start from one position to the left of I. So whatever is the base element I'm picking, that is the first position in unsorted array. I want to start the inner loop from the last element of sorted array. So I should move one step to the left. So my J will be equal to I minus 1. So from J, what I'll do? I'll start a while loop. While what should I do? J should always be greater than or equal to 0 because otherwise it will go beyond that array to the left side. That should not happen. So first condition is J should be greater than or equal to 0. And what is the second condition? I have to do this till the point the element is larger than my base element. So AR of J is greater than array of current. Not array of current because current itself is array of I. Greater than current. When both these conditions are true, what should I do? I should move AR of J one element to the right. So what will I do? I'll do AR of array of J plus 1 is equal to array of J. So I'm moving the element one step to the right. After this, what should I do? I should decrement J because I have to consider the next element. So J is equal to J minus 1. And then whenever this loop is done, what does it mean? It means all the elements that are larger than the base element are already moved one step to the right. So I made a position now for the base element to be inserted. So how do I insert? I'll do AR of J plus 1 is equal to current because current is my base element. What is the next step? So at this point, whenever I come out of this complete loop, my insertion sort algorithm is completed. I can do return. I will return the array. So what is this algorithm doing? It is initially having an initialization for size of array. Then it has an outer loop. What is this outer loop doing? It is selecting the base element, that is first element in the unsorted part, to be considered. So in the first iteration it will be index 1, in the last iteration it will be index n minus 1. After that I'll have a current variable which will store the base element. I'm having a variable current variable which will store base element. Then I'll start the inner loop from the last element of sorted array. And what will I do there? I'll make sure that this j, whatever this variable be, that will always stay within the limits. J is greater than 0, greater than or equal to 0. And I will do moving to the right, that is moving one step to the right. This is the operation. I'll do that till the point that element is larger than my base element, current element. And then I have to do j equal to j minus 1 so that I keep decrementing j and consider next elements to the left. And whenever I'm done with this loop, I know I already have moved all the elements which are larger than the base element to the right. So I can insert current element, whatever I stored in the variable, in the available position. Once I insert that, I have to do this for all the n minus 1 elements from 1 to n minus 1. Once that is done, I'll get a sorted array which I can return. So this is the insertion sort algorithm. What is the time complexity of insertion sort? This step, it takes order of n. There are n different steps, and in each of those steps there is another step which takes again order of n time. So total time complexity in worst cases order of n into order of n, which is order of n square. So this is the time complexity of insertion sort. See, insertion sort has a best case time complexity of order of n. So this is in case your array is already sorted, because if it is already sorted, this inner loop will always run order of 1 time if it is already sorted. So in that case, you have a best case time complexity of order of n, but you generally don't see for best case. You always see for the worst case or even average case. Both the worst and average case of insertion sort are order of n square. And what about the space complexity? You are not using any extra space here other than the constant space used for variables. So space complexity is constant, order of 1, which means this is an in-place sorting algorithm. Moreover, this is a stable sorting algorithm. Why is this stable? Because you are considering elements in the same order in which they were placed in the initial array, and you are placing it in the same sequence, which means if the input array, if there are multiple elements of the same value, the order will be maintained among them. So it is a stable algorithm. It is a stable sorting algorithm which is in place.